This is 6.4 day 2. And the learning target for today is to find the inverse of a power function. We defined what a power function was in day 1, and so we're going to find the inverse of it and to use the horizontal line test. I'll tell you a little bit more about that in a minute. Okay, so the first thing we're going to do is find the inverse. And then it wants us to graph both functions. And then graph f of x and its inverse. So remember, this is how we name the inverse with that -1. So our function is f of x equals 4x squared. And this is a power function. And then they're going to tell us that x has to be greater than, or sorry, not greater than, it's supposed to be less than or equal to 0. Okay, so we'll talk about this in a minute, but what that means is x has to be either 0 or negative numbers. Okay, so we're going to do our steps to find the inverse. This one's set equal to f of x, so the first thing we need to do is set it equal to y. So we're going to replace f of x with y. Okay. Then remember, we need to switch x and y. You did that yesterday. Okay. Then we're going to take this equation and solve for y. Okay. And you also did that yesterday. Okay, so we'd have to move over the 4 with division. And then to undo the squared, we would take the square root. And we need to put our plus or minus. Okay, we can clean this up a little bit and divide these into 2 separate square roots. And then our final answer, you can write this. Remember, the square root of 4 is 2. So plus or minus the square root of x over 2. Or that can also be written as, if you want to pull that fraction out, you can write it like that. Now, because they only wanted 0 and negative values, we actually don't need the plus sign. So I'm going to do 2 things in one step here. I'm going to replace the y with our inverse notation, and I'm just going to use the negative sign. And that comes from that definition at the very beginning. Okay, so this is our inverse function. Okay, now it wants us to graph both the f of x and the inverse function. So we're going to graph that in the same coordinate plane. So let's make our coordinate plane up here. Alright, and I'm going to go by 2's on both axes, so we'll do that a little bit more in a minute when we know what we need. So for our f of x, let's make an XY table. Okay, remember that we can use 0 or negative values, so I'm just going to pick -1 and -2. If I plug in 0 for x, I would get out 0, and I'm up here on this f of x function. If I plug in -1 and square it, that would give me 1 times 4. Plug in -2 and square it, that would give me 4 times 4, which would be 16. Alright, so I need to go up to 16, and I'm doing 2, so 2, 4, 6, 8, 10, 12, 14, 16. Alright, and I'm going to go by 2's on the x's also. 8, 10, 12, 14, 16. Alright, so I have 0, 0, and I actually need to go this way, don't I? -1 would be halfway in between and up to 4, and -2 and up to 16. So what we're getting is only half of a parabola here. The other half over here we can't do because, again, because of how the x was defined. Alright, now we need to graph the inverse function, and once you have the original function, the inverse function is really easy to graph. So because of switching x and y, when we make our xy table, we can just switch x and y from the original function. So this first point won't change, but the next point would become 4, -1, and 16, -2. Okay? So now I'm going to plot these points. 0, 0 would be the same. And now I'm going to do 4, and remember we're going by 2's, down -1, so halfway, and then 16, -2. Okay? So it's hard for me to get. It's going to go like this. I didn't get that point very well, but it's going to go like this, and it's a mirror image of the original function over this line, and this line is y equals x. Okay, so you can kind of tell it's a mirror image over that line, and so this is our inverse, and this was the original one. Alright, now let's talk about the horizontal line test. Earlier this year, we did the vertical line test, and the vertical line test is used to determine if something is a function or not. And the horizontal line test is similar. It's used to determine if the inverse of a function, we'll just call it f, of a function f is also a function. Sometimes when you do the inverse of a function, it turns out that it's not actually a function. And let me remind you that a function means for every x value, there's only one y value. Okay? Alright, now, if you're going to use the horizontal line test, so you would have, if a horizontal line let's cross that out, intersects the graph of f only once, then we know is also a function. Okay, so let's look at some examples here. If I have the graph of a parabola, I think you guys can still see that. So this is the graph of x squared. And I draw a horizontal line. This line is going to cross the graph more than once, okay? 2 spots. So this tells me that this fails the horizontal line test. Horizontal line test. So the inverse is not a function. Now this relates to the example up here that we did. That's why I could only use half of the parabola, because if I have a whole parabola, it's not going to pass the horizontal line test. So sometimes it's limited to the negative numbers, and sometimes it'll be limited to the positive numbers in your homework. Let's look at another graph that you're familiar with. This is the graph of x cubed. Now this graph will pass the horizontal line test because the horizontal line is only going to cross at one spot. And when it passes the horizontal line test, that means the inverse is also a function. Okay, so if I did the inverse of that, it would also be a function.